Hello, in this video we're going to look at two examples of binomial expansion and then we're going to check them on CAS. But binomial, where does this term actually come from? Well, it's best to explain it with an example. So I might want to expand something ridiculous looking like 2x plus 3 to the power of 6. That's going to be a pain to expand, and let's pretend we have no CAS for the moment. Binomial. Binomial means two terms. So the two terms are 2x and plus 3. These are the two terms. Two terms. Binomial, two terms. That's where it comes from, and we're going to expand this. And we're going to expand this using Pascal's triangle. So I'm going to do Pascal's triangle here as a little reference. So you start with 1, then you go 1, 1, then 1, 2, 1, because 1 and 1 give you 2, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1. Alright, let's see. So that's for a 0th power. That's for power of 1. That's power of 2, power of 3, power of 4, power of 5, power of 6. So we're good. We've got Pascal's triangle. That's going to help us work this out. That's going to be very useful to expanding this. But how do we go about it in one line? I mean, how do we actually handle this? I mean, you could do 6 sets of brackets, 2x plus 3, 2x plus 3, 2x plus 3, but that would just take forever. So here's how you do it. I don't want to show you the formula because it's just a bunch of symbols, and I think it's more confusing than if you actually look at what's happening. Here's what's happening. You start with the 2x, and that goes to the power of 6, and then you have the other term times the other term, and that's to the power of 0. And because it's this to the power of 6, the coefficients come from the 6th row of Pascal's triangle. So let's number these. So that's the 0th row, 1st row, 2nd row, 3rd row, 4th row, 5th row, 6th row. So they're going to come from here. So this first coefficient here is going to be 6 choose 0. So we have 6 choose 0 times 2 times x to the power of 6 times 3 to the power of 0. And then what happens is we get the next term by going 6 choose 1. So we bump that up by 1. And then I like to think about it as the weighting of the power. The weighting shifts to the other term 1 unit at a time. So it goes 2x to the power of 5, 3 to the power of 1. Can you see what's happening there? We increment this number down here, and the 2x says, here 3, take one of my powers. I'm gonna lend one to you. They're very friendly like that. Okay, and then we add 6 choose 2, 2x to the power of 4, 3 squared, so it throws at another power, plus, and see if you can come up with the next term. It's going to be 6 choose 3, 2x cubed, 3 cubed, so it's lending it another power again, plus 6 choose 4, 2x all squared, 3 to the power of 4, plus 6 choose 5, 2x to the power of 1, 3 to the power of 5, plus 6 choose 6, 2x to the power of 0, 3 to the power of 6. So if we've done this properly, we should have the same number of terms as we do in this row. So we have 1, 2, 3, 4, 5, 6, 7. Let's check 1, 2, 3, 4, 5, 6, 7. Good. Now it comes to evaluating this. 6 choose 0 is 1. So that's just going to be 1. 2 to the power of 6 is 64. So we're going to get 64 x to the power of 6. And 3 to the power of 0 is just 1. Bam, first term done. Alright, what about here? 6 choose 1 is 6. 2 to the 5 is 32. And then we've got this times 3 business here. So we'll deal with that later. 6 choose 2 is 15. 2 to the power of 4 is 16. 3 squared is 9. 6 choose 3 is 20. 2 cubed is 8. X cubed times 27. Plus, okay, what have we got next? 6 choose 4 is 15. And then we've got 4x squared. 3 to the power of 4 is 81. Plus 6 choose 5, which is 6, times 2x. 3 to the power of 5 is 243. Plus 6 choose 6, which is 1. 2x to the power of 0, 0. 3 to the power of 6 is 729. Alright, let's keep tidying this up. 64x to the power of 6. 3 times 32 is 96. So then we're going to times by 6. So that's 600 minus 24. 600 minus 24 is 576. So we're going to get 576 x to the power of 5. Let me check that another way. That's going to be 192 times 3, which is 600 minus 24 again. Yep, that's right. Alright, let's see. 9 times 16 is 144. 144 times 10 is 1,440 plus half of 1,440. Ooh, that's a tricky one. Alright, I'm going to have to do a little calculation here. I'm stuck here. 15 times 16, 6 fives. 16 times 5 is 80. Then 160. 0, 4, 1, 240. Does that make sense? Yep. And let's times it by 9. 9 4s are 36. 9 2s are 18. 2160. Okay. Plus 2160. X to the power of 4. Okay, this is getting very tricky. 8 times 27. 8 7s are 56. 8 2s are 16. 21, 216. That makes sense. Times 20. So I'm going to times it by 2. 2 6s are 12. 2 1s are 2, 3, 4. So 4320. 4320 x cubed. Okay, 4 times 80 is 320. So it's going to be 324 times 15. 324 times 15. 5 4s are 20. 5 2s are 10. 5 3s are 15, 16. Plus 3, 2, 4, 0, 4, 8, 4. It's 4, 8, 4, 0. X squared. Plus, ooh, okay, 243 times 6. 6 3s are 18, 6 4s are 24, 25, 6 2s are 12, 14, 1, 4, 5, 8 times 2, 2 8s are 16, 2 5s are 10, 11, 2 4s are 8, 9, 1916. X plus 729. Alright, that was more exhausting than I expected. Let's see. So all those are taken care of. Whew. Okay, Mr. Kaz. Let's expand it. So we go menu, and we're going to algebra. Okay, I'm going to have to reload that. That's the binomial theorem for you. Loading, calculate, menu, algebra, expand, and we are wanting to expand. I think the expand doesn't need the argument, so I don't even think you have to put x as the argument, but it doesn't hurt. 2x plus 3 to the power of 6. I don't think you need it. Let's check. No, you don't need it. Alright, let's check my answer. Let's scroll across. 4, 8. Oh, made a mistake there. Alright. There you are. Your fleshy brain can make mistakes. So 4860 and 2916. Hopefully you did better than me. 4860 and 2916. And I'm breaking the cardinal rule, which is don't write over your answer, cross it out and rewrite it. So I made some calculation error there, but the concept is still the same. So see if you can find my calculation error. I'm sure I'll put aside a Freddo for whoever finds exactly in the video where it's up to. I did promise another example, but really the only difference, if you have a negative sign there, is that the sign just flips. So it always starts positive. If you had a negative sign there, it just starts positive and then it just goes negative, positive, negative, positive, negative, positive. That's the only difference. So I don't see the need to do another example. And if you have been, thanks for watching.